Hello, my dear mechanical and civil champions. How are you all? What's up? Please, guys, do join me fast to this wonderful session on fluid statics. So, those who are watching me live, please do respond through the comment section if my audio and visual quality are fine or not. So, in this session, we will be going to discuss only 10 questions. Yes, only 10 questions, but believe me, the difficulty level of each and every question will be as that of your actual GATE examination. That is why I have decided to bring less number of questions, quality questions, so that your fundamentals improves multifold. You develop the confidence to attempt the questions which are going to come in your GATE examination. All right. So please welcome to this session and do let me know if my audio and visual quality are all okay. Hi Anirudh, welcome. Good evening. Namaskar. Adab. Shubh Sandhya. Good evening. Sat Sri Akal. Assalam Walaikum Wanakam. Please mark your presence by writing in the comment section so that we can start this session. Keep your pen, notebook and calculator handy and try to solve as many as questions. Those who will be able to solve all the 10 questions or even more than 80% of the questions, more than 8 questions or 8 or more than 8 questions independently without any help, believe me, you are having strong command in the syllabus, in the subject, and you will definitely get the good marks or almost 100% marks in your fluid mechanics topics in your GATE 2024. All right. So shall we start? Shall we start session? For those who are attending my session for the very first time, Acha Anirudh, thank you very much. So those who miss the live session by chance due to some unavoidable circumstances, please do watch the recording, try to solve the questions. It is equally beneficial, but if you are there, if you can make it to attend the class live, then nothing like that. All right. So this is my quick introduction for those who are seeing me for the very first time. Are you able to hear me? कुछ ऑडियो वीडियो में कोई प्रॉब्लम तो नहीं है? Are you able to see me properly or not? Or are you facing any difficulty? Yes, this is my introduction. I am having more than 10 years of teaching experience in the field of GATE, IES and PSUs. I am mechanical engineering graduate from IIT Delhi. Let me tell you, the session is going to be equally important for civil engineers as well as mechanical engineers, because the syllabus of fluid mechanics for civil students is almost similar to that of mechanical students. I have also cleared engineering services examination, worked in Steel Authority of India Limited for a couple of years, and I am quite comfortable in the mentioned subjects of mechanical engineering, which involves fluid mechanics, heat transfer, complete thermal engineering as well as the industrial engineering. So fluid mechanics is common for civil and mechanical, so that is why the session is important for all your civil as well as mechanical friends. So please do share this session to all your friends who are going to appear for GATE 2024 examination. And this is my mail ID. You can connect with me through the mail ID if you have anything to discuss, and it is always beneficial if you join me on the Telegram, which is Mechanical by Chandrasekhar. The link to join me on the Telegram is already there in the bottom of the screen, and you can also scan this given QR code to join me on the Telegram. So once you become part of my Telegram channel, these many benefits you will be getting. So please settle down fast, sit back, relax and enjoy the beautiful session where we will be discussing 10 important questions which will cover the entire syllabus of fluid statics involving the fluid properties as well as the manometry. The topics which we are going to discuss or which we are going to cover through these 10 questions will be fluid properties, that is the first chapter, like density, compressibility, capillarity, surface tension, viscosity, etc. Then the second part we are going to cover is manometry, about the pressure measurement, how to measure the pressure, how to write the pressure equation. Then we will be going to cover the hydrostatic forces. Hydrostatic forces, the forces exerted by the static fluid on a surface kept in the fluid. And one more topic will be the concept of buoyancy and flotation. This will be the entire syllabus of fluid statics which we will be covering through these 10 questions. So one important information before we start our session, keep on writing in the comment section. That is my humble request, guys. The more you participate, the more you communicate with me, the more energetic I also feel. So I will try to make the session simple, easy and interesting for you, provided you should give your 100% to the session. Try to solve the questions, commit the mistake, do not get afraid of committing mistakes, and keep on sharing your knowledge through the comment section. Keep on asking your doubts, because the more you share your knowledge, the more improvement you develop. All right. So there is a workshop going to be conducted on 25th of October by Richa ma'am at 7:30. She will be guiding the students who are preparing for GATE 2025. She will be discussing the right, absolute, the well-proven strategy for clearing the GATE 2025. You just have to register yourself. No single rupee is charged. It is completely free of cost, but it is very helpful for those students who are in second year or third year, or they have not yet started their preparation. And tomorrow, 22nd of October, there will be a scholarship test. Every Sunday we conduct the scholarship test for GATE aspirants. Based on your performance in the scholarship test, you will be able to avail the discount in our various paid courses. Yes, I am going to show you the question number 1. For that, I need your response, your positivity, your participation. Please write Y in the comment section if you are ready to start solving the questions from the fluid statics. Please everyone do write Y in the comment section. Everyone, those who are watching me live, shall we start? Anirudh is the first one who had given his response. What about others? Baki log, I want everyone to keep responding, keep showing your love, affection, your participation, your presence, your motivation through the comment section, your level of energy through the comment section. Hi Shreyas, good to see you. Franklin, welcome guys. Once again, I welcome you all from the bottom of my heart to this wonderful session where I have handpicked the questions which are having the difficulty level of GATE exam and which will help you to improve your understanding. So I will show you the question. I will give you sufficient time for you to solve first, and then I will provide the solution as well. That is how it is going to work. All right. So let us start with question number 1. Read the question very carefully because they are not straightforward. The questions are not that simple. They are conceptual and they require some in-depth understanding of the concept. So read the question and try to solve it. Yes, Vinod, the one who will give me the correct answer and who will be the first one to give the right answer will get a surprise gift from me. Everyone, read the question very, very carefully and try to solve it. बाकी लोग अपने आप से पढ़िए, समझिए, ट्राई करिए इसको, और जो लोगों को बहुत ज्यादा नॉलेज नहीं है क्वेश्चन के बारे में, टॉपिक के बारे में, दे डू नॉट हैव an idea, if they don't have the idea about the question, I am there to help them out. I will be solving the question as well. So the question says there is a gap delta between two concentric cylinders. If we draw two concentric cylinders, these are the two concentric cylinders, and the gap between the two concentric cylinder is nothing but delta. Each of height h, the height of the cylinder is h. This is the figure, and it is filled with oil. The cylinder, the gap between the cylinder is filled with oil. The question is from the viscosity. The question is from the viscosity. Anirudh, please check your answer once again. The fluid is oil. The torque required to rotate the inner cylinder. There is a rotation in the inner cylinder, and the torque required to rotate the inner cylinder is T. The diameter of the inner cylinder is D. Small d is the diameter of the inner cylinder, right? And the gap delta is very, very less compared to the diameter. So if the gap between the cylinders or between two surfaces is very small, the velocity profile inside the gap, inside the fluid, can be treated as linear. If nothing is given regarding the velocity profile, we can assume the velocity profile in a very small gap to be linear. What will be the expression for the dynamic viscosity of the oil? Anirudh had shared his answer. Do you guys agree with Anirudh, or do you have some other opinion? Or do you require some more time? Everyone, jaldi, jaldi. One way is to check the unit of each and every parameter. If you like that simple, that is one of the options. Check the unit of each and every parameter. The dynamic viscosity is having the unit Pascal second, or we can call it as Newton second per meter square, or we can also call it as kg per meter second. This is the SI unit. So unit can also give you the right answer. It may not give you the correct answer. If two options are having the same unit, then you might have the difficulty in selecting the one which is correct, isn't it? And here what I believe is each and every option is giving the same unit, isn't it? Each and every option will be giving you the same unit. So that is how the questions are framed, so that you cannot use the short trick. Look, the torque developed on the cylinder is tangential force into perpendicular distance. And what is the perpendicular distance? Do you agree that is d by 2? Torque will be equal to tangential force into perpendicular distance, that is d by 2. Hello Sayed, welcome. And how to calculate the tangential force? Do you agree the question is from the viscosity? The question will be solved by using the Newton's law of viscosity. It is from the Newton's law of viscosity, isn't it? So Ft into d by 2, and what is tangential force? That is equal to shear stress into shear area into d by 2. And what is shear stress? That can be written by Newton's law of viscosity. So shear stress is mu into V. V is equal to omega into d by 2, because it is a rotation. Tangential velocity is r omega upon h, gap is delta, upon gap mu v by h. I use h for the gap, but it is delta. Then shear area. Shear area is the contact area of the moving surface and the fluid. So shear area will be pi into d into h into perpendicular distance to get the torque. That will be the expression. The question is to find out the value of mu. So T into delta into this 2 and 2 will become 4, divide by omega into d cube into pi into h, isn't it? Are you getting it or not? 4 delta t upon omega d cube pi h. omega d cube. What is the correct answer? What will be the right answer? What will be the correct answer? Pi will be here in the denominator or in the numerator? Will pi be in the denominator or numerator? Pi will be attached with h. Pi into h into d cube into omega. They will be in the denominator. So the correct answer to this question is option B. Yes, Maniket, well done. Franklin, good, good, good. Thank you very much, guys, for your active and positive participation. That gives the positive vibes. Is the question clear to every one of you? Still, if anybody is facing any difficulty, the question can go to up to power. Power is equal to torque into angular velocity. So if the question is asking you to find the power, then torque multiplied by angular velocity will be the power which is required. The power required is torque into omega. Let us move to the next one. Acha, Anirudh, actually I got confused. I thought it is A. That is why I asked you to check again. But did you check again and got the same answer? Then that is the level of confidence you require. If you have checked it again and if you got the same answer, it means your concepts are crystal clear. Let us move to the next question. Next question, question number 2. Second question on your screen. Wonderful question from the hydrostatic forces. Everyone, please give it a try. अच्छा, आप अनिरुद्ध इसलिए बोल रहे हैं कि मैंने बोला था सरप्राइज गिफ्ट. यस, यू हैव वॉन वन सरप्राइज गिफ्ट. Correct. Again, the one who will get me the correct answer. Let me write down the names of those students who are giving me the correct answer and the fastest one. First question was solved by Anirudh correctly and he gave me the correct answer first. Now let us move to question number 2. Question number 2. Give it a try. The question is from the hydrostatic forces. Hydrostatic force. The question says water is retained. This is water. Here on the left hand side, the fluid is water. Water is retained against a sluice gate in the form of a circular segment. The gate is in the form of a circular segment as shown in figure. If Q and G are the density, yes, Q is not the discharge, Q is the density and G is the acceleration due to gravity. The upward force exerted by the gate on the water per unit depth, and the depth is perpendicular to the plane of the figure is. Again, it is not a numerical as such, but you need to develop the correct expression and get me the answer. The force exerted by the water on the gate will be equal to the force exerted by the gate on the water according to Newton's third law. For every action, there is an equal and opposite reaction. So whether we call it as the force exerted by the gate on the water or the force exerted by the water on the force, they will be same in magnitude, but they will be opposite in direction. Shall we start solving or you need some more time? The radius of the segment is R. Yes, Maniket had given me the answer. Anirudh had also given me the answer. What about others? Anirudh, are you from civil or mechanical? Are you from civil or mechanical? Look, there are two forces exerted by the fluid on the gate. One is, if I divide this into two parts, the top portion of the gate, AB, let me call it as A to B. On AB section, on AB, the force will be exerted by water in downward direction, isn't it? And how to calculate the magnitude? Weight of the fluid which can be contained by the curve up to free surface. this volume will decide the downward force, and then there will be an upward force. Then there will be an upward force on the section BC. On the surface BC, the direction of force will be upward. Why? Because the fluid is in contact, the water is in contact from the bottom, the direction will be upward. The magnitude, to calculate the magnitude, the method remains same. So weight of the fluid which can be contained by the curve up to free surface. If the question asks you to find out the force exerted on BC, you will calculate this volume. This volume multiplied by rho g. Density is not rho, density is taken as Q. And if you want to find out, this is, let me call it as Fv1 downward and Fv2 upward. If the question asks you to find out the force exerted on AB in downward direction, then you will say Fv1, this is the volume. But the question is net upward force. Net force will be equal to, definitely Fv1 is less than Fv2. So Fv net is equal to Fv2 minus Fv1. That is the net upward force exerted by water on the, that is the net upward force exerted by the water on the gate. And we have to remove, we have to subtract this volume. So it will be this volume only into rho into g. Do you agree? So our objective is to find out the volume of ABC. If we are able to find out the volume of ABC into rho into g, will give you the answer. So can we say Q into G into volume of ABC? That is our objective now. That is our objective. Do you understand? So how to find out volume? So can we, let me call it as O. This is O. So can we say volume of ABC is equal to volume of AOBC or ABCO? ABCO minus volume of AOC? Isn't it? Volume of ABC will be equal to the total volume of AOCB minus the volume of this triangle. So volume of the triangle we can easily find out. The radius of the circle is, the radius is R. So can we say this will be R cos theta if this is R? So do you agree this is R cos theta and this will be R sin theta? So this total will be R sin theta plus R sin theta. So we can find out the volume of ABCO is equal to theta upon 2 pi into pi r square. Isn't it? Or 2 theta upon 2 pi. It will be 2 theta by 2 pi. 2 theta is the total angle. 2 theta is the total angle. 2 theta upon 2 pi. The area of the circle, we are talking about the volume and the depth is unity. So we are concerned about the area only. So area of the circle is pi r square. Area of the semicircle is equal to pi upon 2 pi into pi r square. So it is pi r square by 2. So theta upon 2 pi into pi r square will be the area of the segment. Isn't it? So because the angle is 2 theta and minus what is the volume of this? So it is half into base. Base is equal to 2 r sin theta into height is r cos theta. Height is r cos theta. So that is volume. So we can say this 2 getting cancelled out. So it is pi r square into theta minus this 2. Don't cancel it. This 2. So we can say into r square by 2. R square by 2. 2 sin theta cos theta is sin 2 theta. Sin 2 theta. So the volume of ABC, volume of ABC will be equal to, if we take r square common, if we, sorry, yes. Why I am writing pi? I made a mistake now. It will be theta into pi r square. Yes. Pi and pi will get cancelled out. So it will be theta into r square. It will be theta into r square. It will be theta into r square. Then this, if we take r square common, then it will be theta minus sine 2 theta by 2. That is the volume. And what is the force? Net force is equal to rho, density is Q into G into theta minus sine into r square will also be there. Na? into r square, then it will be theta minus sine 2 theta by 2. Do you agree or not? 2 sine theta cos theta is sine 2 theta. So q into g into r square, q into g into r square, theta minus sine 2 theta by 2. What is the correct answer? Again, Anirudh had given me the correct answer. Again, it is Anirudh who had given me the right answer. Do you guys understand the question or not? Everybody, do let me know if the question or the solution is clear to you or not. The objective is to just find out this volume. If you are able to find out this volume, then your job is done. Clear? Yes or no? Please guys, do not forget to share this session to all your friends. Yes, Anirudh, this is the level of difficulty. It cannot go beyond this level. Let us move to the next one. इतना मैं भविष्यवाणी नहीं कर सकता अनिरुद्ध, but whatever I have seen so far, the difficulty level of gate questions, so this is the difficulty level you can expect. The questions can be little easier also, the question can be slightly difficult also, but this is the average difficulty level for your gate paper. All right, let us move to question number 3. Question number 3, and it will be balanced actually. Some of the question you will find little on the higher difficulty level side, and some of the question you will find very, very simple. So it will be a balance. The paper will be completely balanced. Some portion, the portion which is, what happens is normally the portion which is very simple, very easy for everyone, they try to make a little difficult question from that area. But the area which is already very difficult to understand, they try to make simple question. For an example, turbulent flow. They do not ask much difficult question in turbulent flow. They do not ask much difficult question in turbulent flow. So in statics, you can expect a little difficult question. So the next question, very simple question. The question is from the capillarity. Yes, this is NAT type question. You need to give me the answer for this one. Everyone, please give it a try. Yes, Maniket, well done. What is the answer? An open glass capillary tube. If it is a glass tube of 2 mm bore, it means the diameter of the tube is 2 mm, is lowered into a cistern containing mercury. It is kept in a mercury. The fluid is mercury. When glass comes in contact with the mercury, the level goes down. Why? Because cohesion is more than adhesion. For mercury and glass combination, cohesive force is more than adhesive force. So it is a non-wetting liquid. Theta is, contact angle is greater than 90 degree. And that is why there will be capillary fall. H will be negative. The capillary fall will take place. H will be this. Given that the contact angle between mercury and glass, contact angle theta is equal to 140 degree, surface tension coefficient is 0.484 and gravitational acceleration is 9.81, then what will be the depression of the mercury in the capillary tube below the free surface in the cistern in mm? It is simply formula based, nothing to worry about. 4 sigma cos theta upon rho of mercury into G into D. That is in, we need to find out in millimeter. First calculate it in meter and then we will get, yes, Yes, Archana, that is the correct answer. This time, Anirudh had not got the right answer. For question number 3, Archana had got the correct answer. It will be, the answer should be minus 5.558 meter. Please check. Millimeter. In millimeter, it will be minus 5.558, isn't it? Put the values, you will get the answer. 4 sigma is 0.484 into cos theta, cos of 140. If you take cos of 140 degree, then you will get a negative value. 13,600 into G. G is to be taken as 9.81. G should be taken as 9.81. Yes, Anirudh, theta must be taken as 140 degree. Yes, Sayed, it is asked in millimeter. That is why it is 5.558 millimeter into D. D is the diameter, 2 into 10 to the power minus 3 meter. So your answer will be in meter, and convert it into millimeter. You will get minus 5.558. Please check and do let me know if you guys are getting this value or not. Question number 3. So Archana had given me the correct answer first for question number 3. Let us move to question number 4. If you are all fine with the solution, please allow me to proceed further. But if you have any difficulty, you are most welcome to ask me. So there is a mega mock test. It is already over now. Today is the last day for this mega mock test. If you have not appeared for it yet, do register yourself and appear for the test. Tomorrow the results will be announced, and based on your performance in the mock test, you can get our test series on the discounted prices. So this is the entire schedule for all India Open mock tests and along with the syllabus. So the next test will be starting from 28th of October, 12 noon to, and the results to 3rd of November, and the results will be announced on 4th of November. So this will be the syllabus for the next. Fluid mechanics will be in the next mock test. Strength of materials and power plant engineering will be part of the next mock test. All right. So let us move to the next question. Question number 4. Simple question. Question number 4. Everyone, please give it a try. Question number 4, please give it a try, everyone. And let me know the answer. Let me see who will be the fastest finger first. This is simple again from the viscosity. Simple question again from the viscosity. In a parallel plate configuration shown, steady flow of an incompressible Newtonian fluid is established by moving the top plate with a constant speed. The top plate is moving with a constant speed of 1 meter per second. The top plate is moving with a constant speed of 1 meter per second. If the force required on the top plate to support this motion is 0.5 Newton per unit area. So force per unit area is given. Here the force per unit area is given as 0.5 Newton per meter square of the plate. Then the viscosity of the fluid is, the unit should be Newton second per meter square. What will be the viscosity? Your answer should be Newton second per meter square. Your answer has to be Newton second per meter square or Pascal second or kg per meter second. Don't give me your answer in poise. Don't give the answer in poise. Give your answer in Newton second per meter square. Question is very simple. Yes, Sayed, well done. Anirudh, that is not correct. Sayyad had given the right answer this time. 0.005. 0.005 will be the correct answer. So shear force per unit area is nothing but tau. So tau is equal to mu into V by H. We assume the linear velocity profile. So du by dy can be taken as V by H for linear velocity profile. H is 10 mm. V is 1 meter per second. So viscosity is equal to shear stress, that is 0.5 into H, 10 mm. So it is 0.01 upon velocity. Velocity is 1 meter per second. So 0.5 into 0.01. So it will be 0.005 Pascal second. 0.005 will be the answer. Yes, Aniket, Vinod, well done. Good, good, good. Let us move to the next one, question number 5th. Shall we move to question number 5th? Again, beautiful question from the hydrostatic force. Everyone, give it a try. Tomorrow, the topic will be fluid kinematics. Again, we will discuss 10 questions from the kinematics in tomorrow's session, and the session timing will be 4 p.m. Tomorrow, I will be having this session at 4 p.m. Not at 6 p.m., but the session will be at 4 p.m. tomorrow. All right. Try to solve this one. It is simple. You should give your answer in kilonewton. Let us see who will be giving me the correct answer first. We are halfway now. Everyone, please give it a try. There is a semicircular gate of radius 1 meter. Radius is 1 meter. Right? Is placed at the bottom of water reservoir. This is the water reservoir. And the gate is placed at the bottom. This is the gate, semicircular gate. The hydrostatic force per unit width of the cylindrical gate in y direction. Y direction means in vertical direction. The question is to find out the hydrostatic force per unit width of the gate in y direction. Gravitational acceleration is taken as 9.8 and density of water. Do not take some other value, and density of water is taken as 1000. The fluid is water. It is water. The density of water should be taken as 1000 kg per meter cube. Vinod 46.22. Maniket 47. What about others? Anirudh 15.4 kilonewton is the right answer. 15.4 kilonewton is the correct answer. 15.4. Well done, Anirudh. Good. Keep it up. Look, again the question is similar to the previous question. If you see, if you break this into two parts, on the top curve, there is a downward force and the force, magnitude of force will be corresponding to this volume. This is the downward force. On the bottom curve, there is an upward force and the weight of the fluid which can be contained by the curve up to free surface. This will be the upward force. And this will be corresponding to this volume. So we are interested in net force. So net force will be corresponding to volume of semi-cylinder. Net force will be in upward direction and corresponding to volume of the semi-cylinder. Are you getting it? So it is very simple. So Fe net is equal to rho of water into G into what is the volume of semi-cylinder? Pi r square into L by 2. So put the value, you will get the answer. If your answer should be in kilonewton, that will give you the Newton. If your answer has to be in kilonewton, then density of water divided by 1000 will be 1. So 9.8 into pi. What is the radius? Radius is 1 meter. The radius is 1 meter by 2. And the width can be taken as 1 unit width. So it will be 9.8 pi by 2 kilonewton will be the correct answer. 9.8 pi by 2. 9.8 into pi by 2, isn't it? What will be the answer? 9.8 pi divided by 2. It will be 15.393. It will be 15.393 or 15.4 will be the right answer. Can you find out the horizontal force? Who will find the horizontal force? FH. FH will be equal to rho into G into area of the vertical projection area of the curve. So it will be 1 into 1 into x bar. X bar is the depth of centroid of the vertical projection. What is the value of x bar? What will be the value of x bar? Isn't it 2.5? Isn't it 2.5? This will be Newton. In kilonewton, it will be 9.8 into 2.5. In kilonewton, 9.8 into 2.5 will be the answer. 24.5 kilonewton will be the horizontal force and vertical force will be 15.4 kilonewton. It will be 24.5, Archana. Isn't it? Centroid of the vertical projection from the free surface 2.5. Sorry, radius is 1. Sorry, my mistake. Radius is equal to 1. It is the diameter 2. So it is 1, 3. It should be 3. It should be 3. Isn't it? And there is a problem actually. Yes, the radius is 1 meter. So diameter is 2. So it is 2 meter by 1 meter. So it is 2 into 1 into 3 will give you the answer. 9.8 into 6. 9.8 into 6 kilonewton. 9.8 into 6. Isn't it? 58.8. Is there any confusion in FH? 58.8 will be the value of FH. Are you getting it? Let us move to the next question. Question number 6. Shall we move to the question number 6? Radius is 1 meter, diameter is 2 meter. So if we take the vertical projection will be 2 by 1 and the centroid will be, this will be 1. So depth of x bar will be equal to 3 meter. 58.8 will be the correct answer for FH. Let us move to the next one. Question number 6. Question number 6 on your screen. Try to solve question number 6. Question number 6. The question says a block is floating at the oil water interface as shown in figure. There is some oil, there is some water. Water is at the bottom because density of water is always greater than density of oil. That is why water is at the bottom and oil will be at the top. Right? The density of oil is 2/3 of that of water. Density of oil is equal to 2/3 of density of water. Given that the density of block is 800 kg per meter cube and that of water is 1000, the fraction of total height of the block in oil is, yes, what will be the fraction of total height of the block in oil? If we assume total height of the block as capital H and height of the block inside oil is, let us say, small h. So this will be capital H minus small h. Area of the block is, let us say, A. Isn't it? So can we say the question is to find out small h by capital H is how much? What is the answer? What will be the answer? We want answer, Anirudh. Your concept is clear, correct? But what should be the answer? That is what matters. So for vertical equilibrium, For the vertical equilibrium, we can say buoyant force is equal to weight, isn't it? Or weight of the block must be equal to buoyant force by water plus oil. Water and oil both will exert buoyant force. So weight of the block is density of the block into G into volume of the block is A into H is equal to what is the buoyant force? Buoyant force will be equal to some portion is in the water. So it will be weight of water displaced, density of water into G into A into capital H minus small h plus then density of oil into G into A into small h. G is getting cancelled out from each and every term. Area getting cancelled out from each and every term. Yes, Aniket. Yes, Anirudh. Well done. 0.6 will be the correct answer. It will be 0.6. The right answer to this question is 0.6. So density of the block is 800. Then capital H, density of water is, let us say 1000, or let me call it as density of water into H minus density of water into small h plus density of oil is 2 by 3 density of water into H. So separate the variables, separate the terms. Now we can say, so it will be density of water is 1000. So it will be 1000 minus 800 into H is equal to, then you will get it 1 minus, so 1 by 3 into density of water into small h. So it is 200 into capital H is equal to 1000 by 3 into small h, isn't it? So small h by capital H will be equal to 200 into 3, 600 by 1000. So that is 0.6 will be the answer. 0.6 will be the answer. Acha. Okay, Vaniket, you are enjoying. So I hope you guys are enjoying the festival season, but at the same time, do not skip your studies. Do not make the studies discontinuous. The next one, question number 7 on your screen. Question number 7 on the screen. Try to get me the answer for question number 7. Read the question. It is NAT and find the answer. The question says, in a 5 meter deep vertical cylindrical tank, there is a tank having 5 meter depth. Water is filled up to a level of 3 meter. There is water at the bottom up to 3 meter. And the remaining space is filled with oil. The remaining space is filled with oil. That is 2 meter. Having the specific gravity 0.88. Assume density of water as 1000 kg per meter cube and acceleration due to gravity as 10. You are supposed to take acceleration due to gravity as 10. The gauge pressure in kilonewton per meter square rounded off to the first decimal place at a depth of 2.5 meter from the top of the tank will be. At a depth of 2.5 meter from the top of the tank, what will be the pressure? The question is from the manometry. And your answer should be in kilonewton per meter square. And do not forget to take G as 10. These are the some of the conceptual mistakes students commit. Yes, Anirudh, we have taken. I had taken. What is the answer to this one? So you are part of vision batch, Anirudh? You are there in vision batch? So the question is, yes, in paid classes only. The answer to this question is 22.6. Well done. The answer will be 22.6 in kilonewton per meter square. Yes, Vinod, well done. Is this your first answer? Correct answer than everybody else. So the distance is 2.5. We need to find out the pressure at a depth of 2.5 meter. It means the point is in water. It means the point is in water. So we can say P is equal to rho foil into G into 2 meter plus, then we are traveling in water into G. We are traveling only 0.5 meter in water. 0.5. That will give you in Newton per meter square. That will give you the answer in Newton per meter square. If we want in kilonewton, G should be taken as 10. If we want in kilonewton, then we should take it as, so we can say density is 880 into 10. So it will be density of oil 0.88 into 2 plus 1 into 0.5 into 10 kilonewton per meter square. This will be the answer. Multiply by 10. So it will be 8.8 into 2 plus 5 kilonewton per meter square. That will be the answer. What is 8.8 into 2? 17.6 plus 5. How much is that? 22.6 kilonewton per meter square. That will be the answer. Anirudh, I will check. Let us move to the next one. But before that, there is another information I would like to share with all of you. We are running the crash course for revision of the entire syllabus for GATE 2024 aspirants, where we provide you the live classes, recorded lecture, study materials, quizzes, mock test, everything is provided through this crash course. So you can join and do the revision in the most efficient manner for GATE 2024. But if you are targeting GATE 2025 or 2026, we have recently announced the Vision GATE 2025 as well as 2026. Again, we are providing you the live classes along with the study notes and the test, mock test and the practice quizzes as well. So you can contact the mentioned number for more clarity about these courses. If you are interested, you can talk to the counselor and get yourself enrolled as early as possible so that you should not miss anything in the syllabus. All right. So let us move to the next question. This is not question number 1. This is question number 8. Question number 8 on your screen. Question number 8. This is wonderful question. Solve this one. Let me see who will get me the answer for this one. Question number 8. And if you are unable to solve these questions here, please try these questions again. Do try these questions again. That will boost up your confidence and that will help you to improve your understanding about the statics part. So these are wonderful questions. Try to solve them at home as well. There is a dam with a curved surface shown in figure. The dam is having a curved surface and the fluid is on the right hand side. This is where the fluid is. The fluid is on the right hand side. And the cross sectional area of the dam shaded portion is 100 meter square and its centroid of the dam, that is G, is at x is equal to, it is x bar. It is x bar. It is x bar, that is 10 meter. The centroid is at 10 meter. The vertical component of hydrostatic force Fz is acting at the distance xp. It is acting at a distance xp. The value of xp is, what will be the value of xp? If I extend this, figure up to this, the total area is, let us say, 80. This is the total area. Let me call it as O, then A, then B and C. The total area is OABC, and the centroid of the total area is 7.5. So what we can say, net moment about OA must be equal to 0. Net moment about OA must be 0. So there are three surfaces. This is number 1. This is number 2. And the overall is 80. The total area is 80. So what we can say, area into perpendicular distance. So we can say 80 total area into what will be the perpendicular distance, because OC is equal to 15 meter. So do you agree it will be 7.5 is equal to A1 into the centroid of 1 is x bar plus A2. This is A2. The A2 is the volume of ABC. So the hydrostatic force passes through, the vertical hydrostatic force passes through the centroid of 2. So this is XP, isn't it? Do you guys understand this equation? Do you understand this equation or not? So from here, what is the total area? Total area is 40 into 15 into 7.5 is equal to what is A1, area of 1. What is A1? The area is given as 100 meter square shaded portion. 100 into what is x bar? X bar is 10 plus what is A2? Can we find out A2? So A2 will be equal to, can we say A2 is equal to 40 into 15 minus 100? Minus 100 into XP. So we can find out the value of XP. Now we can find out the value of XP. What is the value of XP? What is the value of XP? Can you guys solve it and let me know? $40 into 15 is how much? 600. So 600 into 7.5 minus 1000 divide by 500. 7 will be the answer. 7 meter will be the answer. XP will be equal to 7 meter. Isn't it? It will be 7 meter. So the remaining question I am giving as assignment. Try to solve these questions at home and bring me the answer. Share me the answer through the WhatsApp, or you can share your answer through the Telegram channel. Alright. And this is the common data question 10 and 11. Also give it a try. Question number 10. Simple, and 11 question. So these are the two questions I am giving you for the assignment, and tomorrow I will be coming live at 4 p.m. and we will discuss the kinematics, the 10 most beautiful question from the kinematics of the fluid flow. All right. So that is all from my side, and this 10 ka Dam series is having these 4 important sessions from the fluid mechanics. Today's session is all over. Tomorrow kinematics at 4 p.m. Day after tomorrow, Sunday, 11 a.m. we will discuss dynamics, and 23rd, that is on Monday, real flow will be discussed at 6 p.m. So take care of this schedule and try to join me with your full preparation, with your full revision. That is all from my side, guys. Thank you very much for joining in. You can scan the QR code to be part of my Telegram channel, or you can share your answer through the email ID as well, or you can join me on the Telegram by scanning this QR code. All right. So see you tomorrow at 4. Till then, enjoy. Take care. Have a good day and a great future ahead. Thank you and Jai Hind.